Now we're supposed to be talking about polynomials here, right? But to define a polynomial, we really need to start with something a little smaller, a little simpler, called a monomial. And a monomial is just the product of a number and one or more variables, right? So let's take a look. I think it's easier if you look at some examples, right? So I've got a few here for us to look at. Everything on the left-hand side is a monomial, right? 3x squared, for example, this is equal to 3 times x times x. So it is a number times one or more variables. And of course, we don't usually write x times x, right? Mathematicians, we like our shorthands. So we usually write x times x as x squared. Right, 7ab squared, that qualifies, right? There's more than one variable here. We have an a and a b, but that's okay. 65 is also a monomial. You might not think it at first, right? Because there's no variable there. But that's okay. The rule doesn't require that there be a variable, right? Just that there has to be obviously something there. We don't want to have nothing at all. So the fact that there's just a number, yeah, that's fine. And x squared over 3, yeah, that is also. Remember, this is the same as 1/3 1/3 times x squared, right? So this is a number times variables as well. Okay, now on the other side, we have some things that are not monomials, right? Things that have variables in the denominator, those don't count. Things that have square roots, right? Or really any non-integer exponent, like that 2/3. Remember, this square root of x, you could also write that x to the 1/2. Yet those don't count as monomials either. Okay, so a polynomial is just a bunch of monomials added together. Right? It's all polynomial is. And you notice how we're naming these things, right? Monomial, mono is the Greek for one. Right? A monomial has one part, where a polynomial has a bunch of monomials all combined together. So I have really the formal definition of a polynomial here, and I know it looks a bit of a hot mess, right? But let's just take a look and break this down a little bit, and I think it's all going to end up being pretty familiar. These a values here, 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 right? All of these a values, those are all just numbers, right? Those are the number part of the monomial definition. And these x parts, here, 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 and so on, those are just the variables, right? Variables raised to a positive, non-negative integer exponent. Right? So this really does match our kind of heuristic definition from the previous slide. It just makes it all a little more formal if you find yourself in a situation where you need this kind of thing. So I have some rules here. Right? If you're given an expression and you're asked, is this a monomial or is this a polynomial? A few simple things you can look at to decide real quick if the answer is no. Right? It isn't a polynomial if there's variables in the denominator. It isn't a polynomial if it has exponents that aren't positive integers. It isn't a polynomial if it has any kind of special function like a logarithm or a trig function. And be careful with simplifying first, right? Especially if you're getting a variable out of the denominator, right? The rule here is you can simplify the number parts, right? Because 2/4, you can make that 1/2 and that's fine, right? But if you simplify in a way that takes a variable out of the denominator, that's kind of not a valid approach, all right? If there's a variable in the denominator, even unsimplified, then the answer is no, it's not a polynomial. Okay, so again, I got some examples here, right? Polynomials on the left side, not polynomials on the right. I think it's a little more instructive to look at the not polynomial side and see why we're ruling these out. Here, we have a variable in the denominator. That's against the rules. The square root of x, that would be x to the 1/2. That's a non-integer exponent. That doesn't work. Now with this one, we could simplify this to 6y cubed. In fact, if you were taking a basic algebra class, you saw this quiz or test question, that's probably exactly what the teacher would expect you to do. But those two things are actually not equal to each other. The expression on the left-hand side is not defined when y equals 0, where the expression on the right-hand side is. And polynomials have to be defined everywhere for every possible real or even complex number. Since the left-hand side isn't defined at y equals 0, we have to rule that out and say, no, in fact, that one is not going to count as a polynomial. I've just got a few more names here, a few more definitions. The terms of a polynomial are just those individual monomial pieces that are being added together. The coefficients are the number parts that we put at the beginning of each monomial. And the leading coefficient is the coefficient of the term with the biggest exponent. And you got to be careful. That one can trip you up, right? You might be given one where the exponents aren't in order, right? Where the biggest exponent isn't the first term. That's a little sloppy. This isn't really a hard and fast rule, but just in general, when we're writing a polynomial, we'll do it so the exponents are in decreasing order. But some teacher or whatever might throw you a curveball, so be sure you check for that first. So we've got some examples here, right, for us to look at. This first polynomial has two terms, right? There's the 5x and the 3. It has two coefficients, the 5 and the 3, and the leading coefficient is the 5. All right, so let's try this with the second one, right? See what's going on here. This one has three terms. I would say they are x squared, negative 5x, and 2. Watch how I'm treating that negative sign here, right? The coefficients are 1. Yes, that does have a coefficient, even though it's not written, right? Every term always has a coefficient. Negative 5 here, and 2, the leading coefficient is that 1. All right, so one more here. This one has exactly that trick that I was warning you about on the last slide. The terms are 3x to the 4th, 5x to the 7th, and negative 5. The coefficients are 3, 5, and negative 5. And here's the tricky part. The leading coefficient is 5. This term here has the biggest exponent. So that's the one that gets to have the leading coefficient. All right, so the next slide, we're going to kind of continue a little bit with some definitions. We categorize polynomials in a number of different ways. Right? In the next lecture, we're going to take a look at what some of those ways are.